First thing I want to know is how was your experience of doing the last assignment? I thought that was a fun experiment assignment, right? Where I asked you to look at the history of microservices and all that. So, anybody wants to just share what they've learned?
I can share. So I was going through the history. I didn't go much into the history because I realized that the REST APIs were introduced around 2000, so it didn't make sense to go way back then. But I looked at the SOAP and I realized that they were using XML for payloads, and it was a bit complex to manage. So that's how they came to introduce REST API so that it is much easier.
That is right. Yes. Anybody else found anything interesting in their research? Okay. Now, because you've done the research, if I tell something, it might make more sense. So let me start drawing some nice diagrams. This will be from memory. Okay, I'm not prepared for this, so let's see how this will go. Yeah. Let me. Shall we? Okay. Let us actually do here. Oh, nice to see Ravi is here. So am I sharing the screen yet? I'm not sharing. Let me first let me share the screen and you can see what I'm doing. For the benefit of Ravi and anybody who's joined recently, this is a Java Springboot class, but because we're still in the early stage with the Java class, we are now doing microservices. So we started watching some microservices videos and all that. So now in the previous class, I had asked everybody to do some research on how we came to microservices. So it's good to have some sort of an idea of where we started from. Then you can see the benefits and drawbacks of this new things. Okay, so let me open on my. I don't want that one. Dot one. Okay, let me use the other one then. This one I don't want that now. Okay, no more workspace. We'll create here. Okay, so in that one, in assets, let us create a diagram. How come there's no folder called diagrams there? Create diagrams, and then in that say new file, call it micro services history. Now we are using camel case nowadays. It makes it easier. Can we draw and center? I don't want center layout. Okay, and show grid. By the way, I'd suggested all of you to start using the keyboard shortcuts on this one. Hopefully, you've started using it. 2 is for rectangle. Yeah, so you're there. 2 is for rectangle. 2 or R. Yeah, and generally, you can see what the keyboard shortcuts are. Any modern web app by doing question mark. If you do question mark, it will tell you all the shortcuts. I think you know about this, right? On any app, for example, even on say Gmail, this is good to know if you don't know already. Then your speed will increase tremendously. Question mark, and there are lots of shortcuts like that which you can use. Did anybody not know this? Please raise your hands. 1. Okay. 2. It's okay. No, it's okay not to know because these things are hidden. So these are only for people who in the know, right? So what does is then you can start using the keyboard shortcuts. Go up and down. I'm not using the mouse. Yeah, I can select something. I can open something. Everything on keyboard. It's blazingly fast. So, and you can see that in many places actually. Gmail is done. Where else is it really good? GitHub. All programmer oriented stuff will always have question mark. First thing you do is do a question mark. Then you can go. You can say GN, go to notifications. Okay. So it's very quick. So you have to know the first thing you just ask the question mark and then yeah. So Gmail that it's there on Confluence, Jira, and all those things as well. Okay. Here also it will be there. Question mark. If you want to go to day view, week view, month view, it works on all those things. It's good to know these things. Yeah. So here, let's come back to our diagram. Here, 2 is for rectangle. So yeah, the way to understand history of anything is like you never have a clear-cut point when people stop doing one thing and start another thing. That's why if you see REST services, it started in 2000. Not started. The initial paper by Roy Fielding was done in 2000. That's when he suggested. But until recently, nobody even looked at it, or at least the industry didn't look at it. There's always a divergence between what the academics figure out and what the industry does. There's a lot of divergence. Okay, so in the past, as first of all, before we go into the past, you should have to know this is the main PC, right? Or mainframe computer, or whatever. How much time do you have? 23. Shall I go even further? Yeah, let me say mainframe only. Mainframe. Even before that, you have that big machine. I asked you to see that movie, right? Where it's about Alan Turing's movie. What is it called? I forgot the name. Uh,
Imitation games.
Imitation Game. Yeah, see that movie to know how the initial computer was. It was a huge machine, like with lots of cubes and everything. So then it became mainframe, which IBM did in the 1960s. You had the mainframe, is one huge computer, and then people were having what was called dumb terminals. The reason I'm telling you this is because you'll see progress is never in one. You never go in one way. It seems like it comes back, goes back, comes back, goes back. It keeps going down. So I'll show you how we again come to this. So we used to have a dumb terminal, and this was the most powerful. This is a very powerful computer somewhere along, and all the people in the bank, like for example, if you had a bank, large bank here, these had people sitting in behind dumb terminals. This terminal was just plain terminal, did nothing. Whatever the command they wrote, that would actually travel through internet, went to that mainframe, and then the response came back. Yeah, that's how it used to be. This was nothing. From there, people realized it's this. If we started having PCs, the advantage of PC was rather than dumb terminal, this was a PC, powerful. Yeah, because this was powerful, you could execute some code here. You didn't really need that big and strong computer. You had people called it a server in those days. Server. This was called a client, and this was server. So you had programs installed here, and you had servers services running there. You could make a call from here till there. That used to work, but this was more powerful. So this could do some independent work. So what you could do was you can ask for something, and the server will give some data, and you could work on it here. Whereas here, all the database work also was done here. The database was here. Database calling was also here. That was say DB. Yeah. The client part also was here. Everything was in one place. Here, the client part is here. So how the form looks and all that stuff could have been done here. But then the problem with this was, like, if you had these millions of these, like everybody had one. Yeah. So you had millions of these. So these had to be installed individually on your PCs. Even if you could talk, if you had some program, say, which allowed you to look at stocks or whatever. Yeah. This was a application that had to be installed on each of the PCs, and then they could talk to them. But that was a big pain for them. So they said, let me start having the same server. Yeah. And then they said, let me have an application, HTML. You'll use HTML to show pages. And then they had JavaScript. This is way back in 1999, 2000. I actually worked in an application where they used JavaScript as the sole client. Yeah. So you could do all the stuff that you could do in JavaScript and still do very similar sort of an application. It was not as good as this one. Even till recently, they were not that good. This web application. This is what they call a web application. The advantage of this is this JavaScript. Hope you're following it. What I'm saying makes sense. The advantage was this JavaScript was actually here. When you make a call, this JavaScript gets downloaded. What is the advantage of that? Then you don't have to have somebody admin doing the installations. Otherwise, the admin had to install this on every PC you had, the client. This was painful. Whereas this, the JavaScript actually comes with every request you make. This is the entire application. This built your animations and whatever you wanted came here. That's what people did. Now, to do this, because this JavaScript has to come and whatever the HTML has to be done, right? That they started doing using stuff like, I'm saying Java, but you could do it in any programming language. So then you had, sorry, what am I doing? Control plus, is it? Yeah, okay. Okay, how much more time we have? Another 18 minutes. Okay, that's good. So then you had something like Java will create these HTML pages and JavaScript pages and whatever form you want based on your request. This is your request. We'll send a response back. Yeah. So if the request was say, if the request was say, get me customer information info, the response would be, this is the request, for example, request. Then the response would be type public. The response would be HTML plus JavaScript. And you had this browser here rather than the client. Yeah, this browser, let us call this browser, would know how to render that, means how to show that. We'll take the HTML and JavaScript. So this processing from request to response was done in Java. And people used to use something called servlets at the time, or even JSP, some server side programs, right? This sort of worked. Yeah, but then it was not as powerful as this. They did some basic manipulation. Take the request, get me the customer info. It will be like HTML / get me the stuff like that, and then they did this one, response HTML. Okay, so then they said, okay, let us make it this better. So they said, let me, instead of having just plain servlets and JSP, let me actually break that up into several different things. They started saying this thing will be in 3 layers, for example. Should I do? Yeah, I'll do a big one like that. And then 1, 2, 3. Okay. So here they said, let me have database code that talks to the database. You have, say, Oracle here, for example. In those days, they used to use Oracle. Even now, they use Oracle. This is Java application. This whole thing is Java application, but this is much more beefier. So this is Java. This is, you have database code, and then you have here you write business service code. Business service code. Let me actually save this. So yeah, let me first do refresh, and then is it not showing me here repositories? where am I doing this? I'm doing this in Springboot course, right? Yeah. So here, all I need to do is save. Yeah. So now database, business, and here you had the presentation logic. Presentation logic basically meant you had this HTML and JSP here. HTML and this JavaScript. You need to know this because this is what happens even now. That's why I'm taking more time to explain this. Yeah. So HTML presentation is done by that one. Business logic is Java code. This is also Java code, talks to the database. That's how they were doing. And where was this residing? This was whole thing. They put in something called application server, app server. Yeah. So you had something called JBoss, had web logic, I think, and lots of stuff like that. App server. Even IBM had something called IBM or whatever. They all were residing in this app server. So this is what they call a monolith these days. Why? Because all of this resides in one giant app server. So the applications were like this. You had database, and whenever you wanted to do something, you'll have lots of different classes that the same thing. But the whole thing will reside in one big place. So, and these were that okay. Did I miss something in between? Remote invocation and all. Okay, okay. So yeah, this was very painful. But what they said was, how do I mix that in this soap? Okay, let's do that. So now all this does at any point in time is just send you HTML and JavaScript. Yeah, but then these are complex logic, right? You need objects and everything. They said, how do we do objects on HTML and JavaScript? Yeah. So they came up with this brilliant idea. We said this HTML and JavaScript, the response will be, instead of HTML, I'll have XML. XML is data. So if it was customer information he wanted, he could have customer, then name is say Alan, and then you'll have more information like that, and then you'll have customer. They said if somebody asks me for customer information rather than whatever I had, this is what I'll send. Yeah. So for now, the client and server needs to understand what is it receiving. They needed some sort of way of representing that. They said, so I will do this, and then I will have some sort of a understanding that I will send this in a protocol. Protocol is basically understanding how this client and server will talk. So they said we will have this defined in a particular format, and then we'll also have this server define certain things. For example, if the client is saying, give me the customer, as long as it sends me an XML with information on what is it asking for, then I'll give you. So what will happen is a client will say send to request to, let us say it's REMQ .net, and then they're telling me, give me the customer. It will not say customer, it would say application, something like that. Yeah, that is how your URL was. And then in the request body, you'll have XML, and in the XML, you'll have customer service, and then whatever parameters the customer service required, ID, for example, it requires ID, all that was there inside that message. This is all XML. Yeah. And this URL had no meaning at all. You could put whatever you wanted there, but entire information was there in the XML. That XML said which service to call, what parameters to give. So this was quite bloated. So Roy Fielding came and said, we have got this HTTP and internet for all these days. We've got certain conventions and all. Why don't we use the existing conventions? So here, all, and if you wanted customer service data, you would say ID and then say, give me the customer. Give. Yeah. On the other hand, you wanted to update it, you would say the same thing. Then you say update here. All this extra data, right? And XML was bloated. You can see if you write comments. I don't know if you guys even seen XML these days, but customer and customer, yeah, they type it twice, right? And then it's quite bloated, and it also duplicated the information. They said rather than this, let us do this. Said uh, we don't need that, right? So he said remq.net. I will say customer and give me one. Yeah. So let me tell you that it is not required. So this is basically something related to customer. He wants first customer. This itself will give you all the information you need, and then the server can respond back with customer information. So what REST does, this is what they call REST. What REST does is it just does the exact same thing, but much more simplified. It doesn't send the information that the server doesn't need. And there are some conventions. When you say customer, it means, say, customer service, and it goes to a particular place in the server. There is an application that understands it and sends the response back. Okay? So it's a basic, and this thing they called SOAP, okay, which stood for Object Protocol. What was this? Simple, simple Object Access Protocol. It was not simple; it was complicated. Basically, they try to define its object as a XML, and they send that over the internet. Okay, so that's where I actually missed some very interesting part in between. I wanted to actually tell you this thing. We started with PC, right? So in the PC, the main difference between PC and all these things is, I should have actually said that slightly earlier. This was your PC, right? In this PC will have that's actually cross access. That's what I should have. How much more time we have got? 4 or 5 minutes. I can say that you have memory and you have disk, right? And if you write a program like C program and all, it reads that memory, reads the disk, writes whatever that's program, right? Distributed computing is different. You have your PC here and you have your server there. Okay, the memory is here. Okay, so there lots of things came. How will you make the call and how will you get the information back? So people said, I'll have an object here, yeah, server object, and I'll have a client object, and this client will make a call to this one. This server is a replica of that over there. Yeah. So for them, this client won't even know that server is somewhere else. It will just make a call here. There will be a proxy. All these different ideas came in those days. Yeah, but all of this had some sort of a problem. What you need to understand is the server lies somewhere else, so it goes over the network. So how far it is, and how expensive it is, all these things mattered. Yeah, that's why this thing was sort of called core by it. Yeah, common object request broker architecture, something like that. And yeah, there were related technologies, Java, remote invocation, and all that used to be there. You don't have to worry about those things now. Yeah, but now we are in this world where you have nice REST, and even this now again the problem is they're saying this is text protocol, right? You send requests in JSON into text, saying text is again heavy. Can I reduce the transfer rate and all? They come up with what was it called? gRPC, I think they call it gRPC, protocol, remote procedure protocol. And if you see Java initially, before this Corba thing, there's something called Java remote invocation. I'm just throwing names here. So you don't have to worry about all these things. So tomorrow, if you see all these things somewhere, these are all old technologies. Java remote invocation, they should do, which is very similar to what they're calling now remote gRPC and all this. The basic problem is sending stuff over the internet. If you send too much text, it's unnecessarily wasting time. So try to send it in a binary format. But when you send binary, but this is what they used to do in the past. Here, like in the mainframe and all, everything was binary. They would because in those days, this, what do you call it? Resources were very expensive. They had to do everything binary, or the formats were binary, and then you had some ways of viewing that. Then they went to textual, because then they said if it's text, they can see the data. Now they come back to gRPC, which again binary. You can't see the text. That's the history. The good thing about the history is that it keeps repeating. But what I'll do, I know I've said too many things in a very short span of time, and as I said, I was not prepared for this. I will have a nice, more prepared one, and we'll have in the next class or something. I'll just tell you from here how we come to microservices. It will be a review also, the next class, and I'll organize this a bit and put some notes, and then it'll be easier for you to understand. Hopefully that made some sort of a sense. This was only overview. That's why I asked you to do the research. Hopefully you've done some sort of research, something's clicked somewhere, right? So in the next class we'll do. Any questions? Anything new you learned that you did not know already? Some of the terms, what I mean, client server probably you never heard. Have you guys heard client server? No problem. Yeah. Yeah.
gRPC was something new. I didn't know about that one.
Yeah.
And
So
yeah.
Yes. Basically, it's a binary format. That's all. But, instead of sending JSON text, they'll just send binary.
And it has come after REST, right?
After REST, exactly. See, that is the reason I said all these things. Then you know which came before or after. Yeah. So gRPC has come after REST. In the next class, I will organize this a bit, like it's all from my memory. So, and I'll actually share you some information in some book somewhere where it's much more organized. I will share that. Okay. Any questions? Okay. So now do the research again. Pick stuff. Do some research on REST. What are the important things of the REST, and see how from there we came to. That's a completely different, because we didn't even come to Docker, right? So then we have to understand how from there we came to Docker, and from there Docker how we came to microservices. It'll be very interesting. Do some research again. Let me see. I don't know how you're telling me the research. Can you all write one document, one markdown document in our repository about what research you've done, just so that I know, and then I'll use that to prepare my notes. Okay. That will be your assignment for today.
Okay, thank you.
Okay.
Thank you.
Thank you all for coming, and see you next time.
Okay, see you. Bye.
Thank you.
Thank you.
Thank you.
Right. Thanks.